Welcome back to the Electronics Inside, the show where we tear down tools, toys and appliances just to find out what's inside. In this episode, I will be tearing down and comparing a pair of game controllers. But specifically, the Xbox Elite Series 2 and the Google Stadia controller. If you know already why I've picked these two controllers, then you're possibly quite a gaming nerd. Let's get inside. Before we jump in, I just wanted to make one really quick note. The Xbox controller actually came in this nice little case, and it's got these 3 pogo pins in the bottom which match up with the underside of the controller, and it's got a little hole in the pouch. So you can actually charge this in the bag, or that will magnetically remove and you can just have that as a charging cradle. That's awesome. I really like that design. Another feature that the Elite Series 2 actually features, you can change the travel on the shoulder buttons. And you also have these configurable paddles which insert and then trigger these little tactile switches on the back, which mean that you can map them to more buttons and features, which means you can use your sort of inside fingers to trigger them. You don't have to sort of move between D-pads and buttons. It's, you know, when you're getting into that sort of reflexes, you're kind of beyond my ability level. I'm just going to get shot in the first 10 seconds of a game. You also come with replaceable thumbsticks and replaceable D-pads, which, for the sake of the teardown, I'm actually going to take off and put to one side right now. So anybody that's watched more than a few episodes of the Electronics Inside will probably know that I not only had, but also still have an N64. Famously, one of the least liked controllers. But I find it really interesting that there's like direct descendants. Like you can see where some of the more modern controllers have taken their cues from. And that N64 controller felt like a direct evolutionary step from sort of purely digital D-pad and button combinations to the buttons up here, which in the N64 were the C's, with the A and B down here, the shoulder buttons, the L and R buttons, trigger on the underside, and an analog stick. I feel like it's closer to a lot of modern stuff than people choose to admit. Oh, it's on. That's actually one of the downsides of the Elite. The normal Xboxes have actually got removable battery packs up here, which can either be AA or replaced for an internal rechargeable battery. And this one can't. This one's all built in. And I wonder how many of these Elites got scrapped because the batteries got too old. Okay, there you go. First view inside. Why aren't the weights the same? The vibration motors I would have thought would have been the same. You want the vibration to be equal in your hand, not more in your left than the right. Why would you do that? I don't know everyone else is like it this one. I'm terrible at eyeballing the size of a Torx screw. You just have to take 2 or 3 attempts to get the right size bit. Oh, they're security Torx. They're not even just Torx. Should we go for an 8 security? I love the idea that you got inside the front plate and you're still challenged by a security screw. An interesting metallic sprung diaphragm type design there. Can't really work out on purpose. It doesn't seem to interact with the actual D-pad anyway. Or maybe it should, and that one's just worn out a little bit more. Is that a honey badger? What am I missing here? Is there some sort of inside joke or reference or project name that made this the honey badger controller? I don't know. I'm not sure. Okay, so we still have a couple of items that sort of fit. Oh, okay. So these mechanisms make up the change in the throw of the triggers, the shoulder triggers, and they appear to be purely mechanical. Actually, I don't think they are purely mechanical because it has to reset what would appear to be the Hall effect sensors on the shoulder buttons to know when fully depressed is made. That's cool. Ooh, I see signs of liquid damage. Got a little bit of a mark around there, and some there. Well, you buy things secondhand off eBay for spares and repairs, you get what you get. Okay, that looks like it should take the battery out. I do like the fact that so far they've just used pogo pins and receiving pads for all the internal connections. It means you're not sort of presented with sort of wiring looms and connectors as you take things apart. They are slightly more prone to fail, or actually slightly more prone to dirt, ingress, and in this case liquid damage perhaps, but it does make assembly, repair and the whole design a lot more modular. It's not the least repairable battery I've ever seen. What are we talking here? Xbox One lithium polymer rechargeable battery, 7.79 watt hours at 3.8 volts, 2050 milliamp hours, with probably an onboard BMU. It's got the charging contacts, 3 pins, make me think probably temperature monitoring. I'm pretty sure there will be aftermarket ones of those available if they aren't already. 2 screws for this tiny little PCB that all it's doing is adjusting the detent. Oh, it's not just doing the detent, I hadn't even thought of that. So these magnets are what hold these sort of additional trigger bars in, obviously on the outside of the case, not on the inside. But they press on these tactile domes here. Tactile domes are not the easiest thing in the world to replace if one of these goes faulty, but it's possible. And on this board we also have these 2 tiny little micro switches, and they are actually micro switches as opposed to tactile switches or tactile domes. So very little force is required from this plastic to actuate those. I think that would probably be a very tricky part to source if you needed to replace that. But then I guess you're probably not changing the settings on your trigger. You'll get to what you're comfortable with and you'll stick with it. So we have these 2 bits here. I think those must be magnets which align, and yeah, you see those pogo pins pointing through from the dock. So let's have a little bit more of a look at the Honey Badger, shall we? So vibration motors are soldered to the PCB. I didn't know. There are actually extra little vibration motors mounted inside the triggers. That must feel weird. So like the triggers giving you haptic feedback as well. Okay, that was unexpected. Okay, so this board seems to use some very chunky pins to like locate itself, which I guess is a nice touch. It gives some robust build quality to it. Nice big metal, maybe 2 metal dowel there. But that's not giving me the ability to take that off. Ooh. Maybe we're going in the top next. Ooh, look. Even the 3.5mm headset jack is not permanently affixed. It's just using the construction of the case to press the pins against some pads on the motherboard. Slightly odd, the clearance around this analog stick in the blue PCB, the Honey Badger PCB, is enormous, but the clearance around it in the right analog stick is much less. Like, I've got to take this cap off, but I don't actually know how. Oh, hold on. Am I missing something glaringly obvious here? Interesting. Why such different construction? Lovely little wire management all over the board. Oh, coax connectors. So the Wi-Fi must be on here, running to antenna on there, or vice versa. Okay, 1 board out with all 4 of those vibration motors. Oh dear, I appear to have snapped one off. So I've just noticed this graphite pad and the B button, which is deeper than the X, Y and A. Does that mean the B goes to a completely different PCB to the other components? I love it when people are more desperate to get the packaging right than the logic of the circuit board. That is definitely a function follows form. Okay, so the D-pad, for all its additional engineering on the injection molded plastics, is still sort of rocks around a plastic part with tactile domes, which I'm sure get gummed up. You've got the normal sort of membrane graphite keys, which again, they actually look quite dirty, could probably do with a clean already. And you've got the magnets in here, which are for Hall effect sensors for the triggers. These 2 tactile switches up here are for the top buttons, the bumpers, and they were feeling a bit questionable when they were in situ, but now they're out, they seem fine. Then you've got some low profile tactile switches, and of course the obligatory USB Type-C connector. Ooh, custom USB Type-C connector. You can see it's actually got a slight chamfer on it. But this is Microsoft. Yeah, I think we're definitely seeing some signs of water damage here. The electronics are a surprisingly small element of this. I guess between the weight of the motors that have to have the space to fling round off-center for vibration, I think I'd expected there to be more circuitry, but wow! They've got Hall effect sensors for your triggers that are right next to the vibration motors. That must have been a challenge to engineer without getting noise on the magnets. It's kind of impressive. So we've got two nice big gold-plated contacts there, which I've just touched and instantly regretted. And I think they must have pressed on this board. These pads here, thinking that they must interface with those, and that's actually quite hard. But all of these pads, they're not actually just tin pads on the PCB. These are actually like laminated, can I call them that? So there's like an exposed pad and then an extra like 1/10 of a millimeter pad applied on top of it and probably soldered on, which just means it's slightly proud of the solder mask, meaning that a big flat pad like that will always make good contact. And I've not noticed that anywhere else, but that's a great idea if you're looking at ways of not using little permanent connectors. Also interested that we have an unpopulated header over here. That looks like a ZIF connector of some kind. That up there must have been for that B that's on the different PCB, whereas you've got the other A, X, Y buttons over here. I find it so interesting that you've got different types of buttons used for the menu and share button versus the Microsoft button, because they have very different sensations to them. There's a clicky tactile feeling versus the soft I want to press it type button. And I can't remember where all those buttons go, so that'll be a fun activity for me later. In terms of equipment on here, we've got this one large Microsoft branded IC up here. It's a lot of discrete components. I think these two are probably the Hall effect sensors that for the triggers. We've got one more down here, but most of it's very, very integrated, and there's not a lot of discrete components on here at all. One thing I did want to check out. So that's the 3.5mm jack for the headset. That looks like it was making contact just there. I wondered if I had a separate audio processing. No, it looks like it's all very, very integrated, which is impressive. Last thing I want to check out on here, really, is locations of antennas. So they're obviously PCB integrated antennas, but they both appear to be on this board at the front, which makes sense because if you're holding this PCB in more or less this orientation, that area here where the two antennas are is at the front and unobstructed. It's line of sight to where your console would typically be. Very neat little package, a lot of cool little features in there. But this, I would say, is, by modern standards, a default controller. Yeah, there's some nice extra features for the Elite series, but this is what most controllers will be like. Direct Wi-Fi connection, some analog handling for an audio output. But what I wanted to understand is the Stadia controller going to be drastically different? We should probably talk about Stadia as a platform before we get into this. Okay, Stadia. Stadia. Why did I think this might yield some interesting results? Well, let me explain what Stadia is, or at this point, as of December 22, was. It was fairly obvious for a while, with everything going to streaming and smart TVs and online everything, so the customer doesn't own anything, that gaming would make some sort of change. And Microsoft, of course, tried this when they launched the Xbox One, saying you would never need to buy a game again and you didn't need discs to play games, but you couldn't trade games with friends, and everybody kicked off. Either way, a good few years down the line, and we've kind of settled into that notion. But the next step was to remove the hardware completely, and that's where game streaming came in. Now, of course, PlayStation and Xbox have done this in certain ways over the years anyway, with remote play and streaming from your own console. But Stadia took it one step further, where the platform was completely cloud-based. All the processing of the game was done in a data center by Google somewhere. You had a controller and you had some sort of smart device or internet-connected screen that you could display the game on. I did actually have a very brief play with this while it was in beta, and you could just play it in Chrome. And the idea of playing this high-powered console quality game in a browser seemed very alien at the time, but actually worked quite well. Now, the reason I think the controller might be interesting is because it's no longer direct Wi-Fi obvious. Like I said, with the Xbox, the antennas are at the front here to connect to a console, which is almost invariably going to be there by the telly in front of you. However, the Stadia can connect through an access point, and it has to be a low latency connection because you've got to send all those commands to a remote data center for processing before the video can be rendered and then sent back down to whatever screen you're using. And I wondered if the latency or the omnidirectional nature of that Wi-Fi, because this could be connected to an AP behind me, an access point behind me, whether that had any major influence on the design or whether most of that was changes in sort of the network stack on the controller. We won't know till we tear it apart, so let's try it. So I hear the secret on this one is to get under there. As I said, Stadia at this point is more or less an X platform. It's going to be formally shut down very early 2023, depending on when you get to watch this. And Google have apologized because when they launched, they were taking very long subscriptions from people. You were buying hardware and they said, yep, don't worry, Stadia will be around for years. And pretty much a year after launch, they're already binning it. I mean, I would have loved to have at least tried this controller to be able to tell you how it felt or what the connection process was like. However, by the time this actually got shipped to me, you couldn't even sign up for Stadia anymore. So I haven't been able to get this connected to anything. Just a super quick catch up. About the 17th of January, Google actually released an update for the Google Stadia controller, which means that you could sever the connection to their cloud services and use it as a Bluetooth controller. So if you have a Stadia controller, there are options for you. Oh, I really tried to get this connected and I couldn't get that to turn on for love nor money. Now I'm taking it apart, it wants to turn on. So this one's actually got a PCB right at the front, which takes, granted, some shallow and not great feeling buttons. These are definitely rubber membranes onto graphite pads, not tactile switches. I'm a little disappointed, I think, with both of these, because game controllers are something which get used a lot under certain conditions. I kind of feel like it would have been nicer to see them both with some kind of easily replaceable battery. I know in the Xbox, a technician could get to it, but the module itself seemed fairly replaceable. I haven't seen what the battery is like in here, but it's definitely not feeling easily replaceable. Interesting, the vibration motors are on connectors. Is that a point for Stadia repairability? This plastic subframe is held on by these two big clips here and here. It seems small, but it's really well holding on. Remarkably similar trigger construction with that sort of single injection molded part that runs across the top. Again, Hall effect sensors for the shoulder buttons. Ooh, QR code. I wonder what that is. That's an interesting little daughter board. Why are you separate? Ah, is that a microphone and audio capture? Come on, this is Google releasing something in 2021. Let's face it, it had Google Assistant built in whether you were using a microphone or not. Okay, drum roll please. 2000 milliamp hour at 7.6 watt hours or 3.8 volts. So slightly, really slightly less capacity than the Xbox. Get the front PCB out and see if I can do this without throwing the buttons all over the place this time. Yep, membranes, pads, tactile switches for the D-pad. Pretty much as expected. The only thing I will say is that little trace for the Stadia button with the LED in the center. That's awesome. That's a cool little trace. The first really obvious thing I would like to point out is the Wi-Fi antenna. Look at it. It's this huge freestanding arrangement. That's the kind of differences I was hoping to see. So yes, it's still biased to forward and back, but that is going to have much better chance of reaching an access point in some other location than those little forward-facing PCB antennas. You can see on the sides these graphite film potentiometers doing all the hard work of translating that motion. And you can see on the sides you've got some more, and you've got the little tactile switches on the end which just support one axle, which depresses when I press the stick, so the sticks aren't symmetrical. Ben Heck actually did a really detailed dive into stick drift on, I think it was an Xbox controller, and he went into the detail of whipping out the microscope and really going in on those graphite film potentiometers to see what was wrong. And it's an interesting video, you should go check it out. Interesting to me that both the Xbox and the Stadia controller both use that graphite film based technique for the analog sticks, and neither of them seem to do anything to abate that, unlike the classic N64 controller, which used a light gate and a perforated sort of webbing on the back of the stick, which was really cool because actually if you pressed your analog stick backwards, held down the two shoulder buttons and pressed start, you could recalibrate where the N64 thought the 0 position was, which meant you could be running by default and get a very slightly higher top speed, and that was not cheating at all. And there's also a lot more discrete chips on here, certainly more than the Xbox, which is boiled down to what looked like one controller. There's nothing on this front board. That must be passing all of its signals. Well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 13 inputs with a common ground, the LEDs on there. So, 16-pin connector is going to cover that without much trouble. All of the intelligence is on here. And we've got a nice little can with a conductive nickel-coated fabric on it. Fortunately, that's nicely soldered down. I don't know if I'll be able to get that off. Okay, I'm really quite pleasantly surprised by the consistent high quality of both of these builds. Both electronically and physically, the build quality of these is lovely. It's a shame that carbon film potentiometers seems to be the only way the industry can find of making a controller, because they just don't last. I've got a controller from my old Xbox One that has failed, and it is stick drift. It would be nice to see some alternatives on future generations. I'm glad we managed to spot the differences between the antennas depending on the infrastructure that these devices are going to be working on. And it's something to bear in mind. Antenna design it's hard. And if you can outsource it by using an external antenna, then I would definitely recommend it. Well, I hope you found this an interesting one. If you've got an idea for a teardown, or there are other controllers you'd like to see torn down for comparison, let me know over at the Element 14 community. Thank you so much for joining me, and I'll see you on the next one.